Hello, this is Paul from Foresight Tech. In this lecture, we are going to find the tangent line for polar curve. Here the summary. To find the polar curve, to find the tangent line, we need to find the slope, right? So suppose we have the polar curve, the polar equation here, and what the slope of the tangent line? Okay, the slope of the tangent line is derivative of y to x. What we need is y to x. However, here is the polar curve, the polar coordinate. We don't have x and y, right? What do we need to do? Okay, so we can change to rectangular system or rectangular equation. Remember, we have a rectangular equation to link, which is x equals r, the distance times cosine theta, y is r times sin theta, right? This is the link. If we give this, and definitely we have what is r? R is a function of theta. Therefore, this is exactly we go to parametric equation. Okay, we just use the results of a parametric equation how to find tangent line here. And the slope is dy dx. So dy dx, we use the chain rule. What are we going to do? Is dy over d is theta. Our parameter is theta, and then over dx over d theta. Okay, if you cancel d theta, that exactly is dy dx. And then the numerate, how to find the dy d theta? Means the equation is here. R is a function of theta. Sin theta is also a function, and the function times the function, the derivative. Remember, that's the product rule. We use the product rule, we get that, which means the derivative of this times sin theta plus r times derivative of sine, right? And the bottom is the same. Okay, is the product rule. If you know, here is just use the product rule. We have the product rule to find what is the formula we have. Look, it's complicated. Okay, it's not easy to memorize this. It's better to use the product rule to this parametric equation. And if they ask us what the concavity at a point, what do we need to do to find the second derivative, right? So if we have the first derivative and take a derivative to x, this means dy dx, and then take a derivative to dx to x again, right? And this take a derivative to x. We use the chain rule again. Is d theta. If we cancel this d theta, definitely is the definition of the second derivative. And because we know this, we plug into, and we also know the numerator and the denominator. Therefore, and you do calculation, you will get this. I did not show you explicit formula because that's too long. Okay, but you know how to find this for yourself. Okay, I give one example to how to use this formula. Okay, I will not go into this. I will going to use what the slope. Okay, use the slope to find the tangent line for a polar curve. Can we see here's the questions. Can you see what are we going to do? Remember this, and then we draw the last topic, right? Draw the graph, look like a heart. This we call the cardioid. Okay, the curve is famous. We need to find the tangent line at this point. Theta equals power 3. Of course, this is not a point. Okay, it's at theta equal this, and then when theta equal this, we can find the point. So how to do these questions? All we need to do is use the slope, right? And I'll show you a formula here first. So what the basic formula we need? I put the slope, the point slope. Okay, all we need is the point slope. Can we see this? Okay, the point slope formula, which is y minus y0. Okay, we use the rectangular. Okay, and equals rectangular form, slope m times x minus x0. All we need to do is find the slope. That's the formula we just gave, and then to find what is the point x0 y0, the point at theta equal that. Wait, I go into tomb so you can see it clearly. Okay, and then what to do? I'm going to find the point first. Okay, it's easy to find the point. So what the point? Over here, The point is this 2, right? What is x 0? X 0 is x, remember the formula, is r times cosine theta, right? Of course, it's theta at this point, so it's what? Is we're going to see r is 1 plus sine at this point, at this theta angle. Okay, this is r times cosine at pi over 3. Okay, and then you do the calculation. This is a special value. Do calculation. What I get? I get 2 plus square root of 3 over 4. Okay, so not a good number, but it is the value for x0. So what is y0? Y0 is r times sine theta. That's the formula. What do we need to do? R is 1, the same. I just copy. It's pi over 3. And then times sine at pi over 3. This is 60 degree. Okay, do calculation. What I get is this 3 plus 2 square root of 3 over 4. Okay, it's not difficult to find this. So the point that we have now is the slope, right? And how to find the slope? We need m. Remember that. So m is not the m. I will not find the m first. I will find dy dx first. Okay, and later we're going to limit the theta at pi over 3 to find m. Okay, what the formula? We're going to put the formula. You remember this a little bit longer formula, right? The top is dr d theta, right? And the sine theta, I just copy the formula a little bit longer. And r times cosine theta. Here is dr d theta times cosine theta minus r times sine theta. Okay, this is the formula, the longer formula, and then plug what we need. I plug r. Okay, r take divided to theta to there. R take divided theta to here. Okay, so get what we need. So I put this. Okay, it's a longer one. R take derivative, which is cosine theta. So we do have cosine theta, and then times sine theta. The plus r. What is r? I plug in. R should be this. 1 plus sine theta. Okay, and longer times cosine theta. So cosine theta, right? 10 times cosine theta. Then minus r is 1 plus sine theta times sine theta. Okay, it's very long. And be patient. So now what do we need to do? Expand the distributor, right? And then we have sine, cosine, sine, cosine, sine. Okay, so you can assign theta, sine, cosine, which means what? You can simplify, right? We can simplify that. Here we also can simplify later. So we're going to simplify up here. After simplify, we get a little bit easy one. Is cosine theta times, see, cosine theta factor out 1 plus 2 times sine, right? 1 plus 2 times sine theta. And at the bottom, we're going to I think you have to use the Pythagorean. This is cosine square. Cosine square is what? Is 1 minus sine square. Okay, 1 minus sine square, and then to do a kind of calculation. Okay, what do I get? Should be this 1 plus sine theta. Okay, and then 1 minus 2 times sine theta. Okay, you're going to do calculation, you will get this. So now we definitely can find out what the slope, right? Okay, so I get the slope here. So m should be equal to what? dy dx. That's a function, and then limit at theta. See here is at pi over 3, which means what? So still longer, but not difficult now. So I copy this to here. Okay, so I copy. This should be cosine pi over 3 times 1 plus 2 times sine at pi over 3. Okay, is longer, but don't worry. 1 plus sine at pi over 3, and then times 1 minus 2 times sine at pi over 3. Still longer. Okay, so all these the special value per log. What do you get? You get I get a -1. Okay. Get a -1 means it goes down, right? Y equals -x. This kind of straight line, almost. And then we know m. We know the point. Per log into the point slope. What do I get? So now I get y minus y0 is there. 3 plus 2 times square 3 over 4 equals m is -1, so I put the -1 here, times x minus x0, that number, 2 plus square root of 3 over 4. So usually we will not stop at here because we know we can simplify, right? Okay, we can simplify, so put this to the right. So we get another form to going to simplify. So here usually we need to simplify because this looks we can simplify to get a simple one. And plus this to the right and distribute. What do I get? I get the final way this y equals negative x plus a number. The number is this 5 plus 3 times square root of 3 over 4. This is looks a little simpler than that one. That's the results I get. Thank you. That's all.